Hi everyone, welcome to the second Makerspace event by the Events Committee. And for today's event, we will focus on the scientific phenomenon tidal waves. So we're going to get introduced to what tidal waves are.
Ah,
So what are tidal waves, right? So tidal waves are water waves that are caused by the gravitational pull of the moon and the sun around the earth. And since the moon is closer to the earth than the sun, the moon exerts a stronger gravitational pull on the earth. Thus, tidal waves are mostly influenced by the moon, and it pulls on large bodies of water and they bulge toward the moon's direction. So we have a simulation of tidal waves, and once Rose goes on that website, we will show you. Um,
ah,
mhm.
okay.
So as you guys can see, you see that the tidal waves have like high ends, and then you see like they have low tides at the other side, right? And this happens when you make a 90-degree angle. So like let's wait until the moon goes to, and then stop it when it's on the line, and then we can show it.
Mm-hmm.
Yeah.
It's kind of close, so I'm just gonna.
Mhm. So you see how it stopped over here, and you see a difference, right? It's not like high waves and then low waves on different sides. It looks somewhat equal. So Rose, can you zoom out, and then we can show something. So you guys see how it's like a 90-degree angle with the sun, the moon, and the earth. When it has this 90-degree angle, that's when it's like similar all around, and it's not like high waves on one side and low waves on the other. But if you continue to play, zoom in, and then continue to play the rotation, and stop it when it's like in the middle of the other side. When it forms like a straight line. Yeah, stop it right now. You guys see how it's like not equal on all sides anymore? It has high ends, high tides, low tides. So if you zoom out, you see that it somewhat forms like a straight line from the sun and the earth and the moon. So when it's at this direction and this position, you know that it has higher tides at some points and then it has lower tides on the other. So that's just one way you can find out how tidal waves work in relation to our solar system.
Yeah. Sorry.
So the tidal wave has a cycle, and it takes place over the course of a month according to the moon's orbit around the Earth. So the high tides, the areas where it was higher, the bulge that has reached the highest height, and it occurs in the Earth's oceans that the moon is overhead. And in the low tides, it's the opposite. It's when the bulge has reached the smallest height. And unlike the high tides, it occurs in the Earth's ocean so that the moon is not overhead. And then you have the spring tides, and this occurs when the sun, moon, and earth are in alignment with each other. So the gravitational pull of the sun adds on to the gravitational pull of the moon, causing the highest high tides and the lowest low tides. So the spring tides occur about twice a month. And then we also have the neap tides, which occur 7 days after the spring tides when the sun and moon are at a right angle to each other. Just like what we mentioned with the 90-degree angle. The gravitational pull of the sun partially cancels out the bulging of the ocean caused by the moon. And then as a result, high tides are lower while the low tides are higher. So many people often confuse tidal waves with tsunamis, and because they look like a tide when approaching land. So, but there's many differences between both. Tidal waves are predictable. They're impacted based on the atmosphere, whereas tsunamis are rare events. Tidal waves are caused by the gravitational influences of the sun, moon, and planets. Meanwhile, tsunamis are caused by a sudden, large displacement of the ocean or the seafloor. And then we also have tidal waves follow currents. They're unlikely to occur near temperate climates or northern countries. Whereas tsunamis, they potentially are able to develop anywhere near a large body of water. And then finally, we have tidal waves. The wavelengths vary from 5 minutes to an hour, whereas tsunamis' wavelengths are way longer. They are 12 hours to about 24 hours, a whole day.
And now we move on to the history, where we can look at Galileo's theory. So Galileo tries to use his tidal theory to prove the movement of the Earth around the sun. He theorized that because of the Earth's motion, borders of the oceans like the Atlantic and Pacific would show one high tide and one low tide per day. The actual modern scientific reasoning that is tides originate in the oceans and progress towards the coastlines, where they appear as a regular rise and fall of the sea surface. When the highest part or crest of the wave reaches a particular location, high tide occurs. Low tide corresponds to the lowest part of the wave, or its trough. Then we go to Newton's law of gravitation. Although Galileo did use the concept of tidal theory, the explanation of tidal waves was not scientifically proven until Newton's explanation with the law of gravitation in 1687. According to Sir Isaac Newton's law of universal gravitation, the gravitational attraction is reflected based on proportionality of the mass and distance of two objects. Newton explained that the gravitational pull of the sun and moon causes the formation of tides. The sun is relatively larger in mass than the moon, but further away from planet Earth, causing its tide attraction to be half of the attraction by the moon, causing the drag and push motion. And then we have our activity.
So we planned an interactive activity with everyone here. So a Jamboard link will be put in the chat. I'll put it in the chat briefly. And then once you have the Jamboard link, you will go on it. So first you will be placed in breakout rooms. So you will have to flip to the side corresponding to your breakout group number. And then in breakout rooms, you have to work with your group members to complete the tidal wave cycle chart. And then once it's completed, your group will decide on a group representative. So just choose one person to leave the breakout room and then come to us to join us in the main room and then check our answers. If there are any incorrect parts, the representative will be informed by us and then we will tell you also there's a mistake. And then you will have to go back in and then fix the problem. If not, then you will get it correct. So you will have about like 10 minutes to do so. And so Rose will assign the breakout rooms. Well, I'll put the link to the Jamboard in the chat. Guys, can you let me know if you can access this? It should be ready for anyone to access. Okay, good. Thank you. So once you go into the breakout rooms, you know how it has like you're invited to like breakout room 1 or breakout room 2, 3, 4. So you will just be put into those breakout rooms, and so in your breakout room you will be working on the Jamboard slide that's dedicated to your group. It says it on the top of the Jamboard. Group 1, group 2, group 3, and so on.
So breakout room should be opening. Oh. Yeah, I'm gonna move some people. Oh, yeah, Surashi, can you like stay for?
Yes. Which group are you
Room 1.
in? Room 1. Okay. Oh, guys, read the instructions. On the first page it says, place the moon. You have everything. I'll say it like you have the positions right. Just label the phases using like spring tide or neap tide. Using
Okay.
post-it. Yeah.
Oh, okay.
Sorry.
Okay.
But
Thank you.
it's
Okay.
Okay, room 2, group 2, I think is complete. You can look at group 2, but the thing is, it's not perfectly the same thing. It's like the right crescents are different, but if you think about the phases, it still works, right?
okay. Yeah,
So,
it does.
so if it's correct, they technically win. But if it's not correct, just let me know. I'll let them know.
What do you think, Rose?
I think it's technically correct. It doesn't have to be the exact same as long as they have like
Yeah, it is.
the right concept.
So are we closing all breakout rooms because they won?
You guys won, but I think we can wait a little bit longer to see how far everyone else comes, and then we'll just like announce that you guys won.
Okay, so I have a question. So they're getting 15 points now.
15. Hold on, what?
Wait.
15 for the entire for
Like in
attending
total.
and then you're getting 5 additional, so they're each getting 20 points. Does that make sense?
Each getting 20 points? Okay, I'll let them know. They're getting 5 additional points.
Tell you group 2. Wait, Rose, we said that we're gonna give them a little more time.
Yeah, so we'll give them like 1 more minute, or
Yeah,
because I'm just looking at what they're doing, and like they're pretty close, like springtide.
Yeah.
Kind of really far, but that's okay.
Okay, I'll go let them know.
We're good on time because the thing.
Yeah. And then we just have the summary, and then we'll be done.
Should we tell?
Yeah, everyone's on the right answer. Okay, I'll do a broad like everyone thing or whatever. How do I do that? Broadcast message to all. Breakout rooms will be closing in 2 minutes or whatever.
So just to let you guys know, group 2-1, they came to us first with the correct answer. And now Rose will just go over what the final product is. But members in group 2, you will get an additional 5 points. So 15 points for the overall event for attending, and then you'll have 5 points for winning. So congrats.
So I guess now we'll just explain, I guess, why these answers are. I feel like Surashi did a really good example, like explaining earlier when showing the simulation. But when the sun, the earth, and the moon are in the straight line, like we noticed before, and like you guys noticed on the Jamboard, the full moon and the new moon are the phases that a spring tide will occur, since the sun's and moon's gravitational pull will add on to each other. The first and third quarter will result in the sun's gravitational pull partially canceling out the moon's bulges, so the first and third quarter moon phases are the neap tides. If you position the moon at those phases, then the sun, earth, and moon will form a right angle. The biggest bulges on the earth represent the high tides, while the smallest represent the low tides. Since the moon is placed at a spring tide, the biggest bulges must also be there. And then these were the sources that were used. I feel like there's more here, but thank you for attending. And yeah, the attendance form was sent to the chat.
So thank you guys so much. So you will get 15 points for attending the overall meeting, just to reconfirm it. So once you fill out the attendance form, you guys are free to leave. Thank you so much for attending today's event.